Hello, I'm David Stockberger, and today I'm going to demonstrate how to do the problem part of Test 1. So I'm in my gradebook for the example student, and I click on Form for the Test 1 problem, and it appears. Now I'm ready to go as soon as I click on the red button, but before I click on the red button, I'm going to do some things. The first is to load an SPSS program that I'd written before to deal with example data. Now I've done the example tests, so I know what I need to do. I will also have loaded a calculator because I know I'll need a calculator. I will have loaded the probability calculator because I know I'll need that. I will also have loaded an Excel worksheet, a blank one, and I'm ready to go. So, without further ado, I start the real test, and I noticed it looks exactly like the example test, but it has 10 additional records. Now I could just add the 10 additional records to the example data file that I'd done earlier, but I'm going to create a new data file. So to do that, I highlight the data on the web page. I right click, I copy it, I go to the Excel spreadsheet, paste it, and then I'm going to save it. And I'm just going to put it on my desktop, and I'll call it temp because I've just created one, and I'll save it. Yes. So I don't need this anymore, so I can just exit out of there. So I've got temp on the desktop as an Excel file. So I'm going to open up an SPSS file. I'm going to open it, and it'll be a data file, and it's on my desktop, and it's called, and it's going to be an Excel file, and it's called temp, and it's opening it, I think. There it is. I'm just going to accept the default, and here's my data file that I just created. Now when I look at it, it has some things I don't like. It has a lot of decimals, which I don't need, and the record size is too big. So I'm going to change the decimals to 0. And I'm going to go over here and change the number of columns. Rather than 12, I'm going to put in 6. Yeah, I'll put in 7. And look at the variable view, or look at the data view, a little bit cleaner. I can at least see the whole page now, and I've got 30. I could compare this with the actual data, but I'm going to trust that I've got it right. Some other things I want to put in the documentation. So to do that, what I'm going to do is I'm going to go to the file that I've already created and take the value labels, and I'm going to paste them into the file that I just created. Now I don't really need the the earlier file, so I'll get rid of it. Because I've done the example, I know there are some variables I need to create, and one of them has to do with a new value for support with 2 levels, with family and all others. So I'll go to transform recode into different variable. I'll choose support is the one I want to recode, and I'll call this support 2 because I have 2 levels. Old and new values. If the value is a 1, we'll keep it a 1. For all other values, we'll make it a 2. So family will be a 1, everything else will be a 2. We'll continue and put in support 2 and OK. Looking at our data view, we'll scroll over a little bit. There's support 2. Our variable view, we'll create another variable. We know we need age squared. So we'll transform compute variable. Target variable will be, we'll call it age 2 or age squared, why not? Age squared, and it will be age times age. Okay, so there's age squared and support. Now we'll go ahead and create a value label for support 2. We created that so that a 1 will be family and a 2 will be all others. And we can clean this up a little bit. We don't need any decimals here. And we'll make these 7 also, just to keep things consistent. And going back to our data view, there we have it. This is the data file we're going to work from. Now we can start doing the test. And the first thing we're going to do is we're going to recreate these 2 tables. The first one is simply a crosstabs table. So I'll go Analyze, Descriptive Statistics, Crosstabs. Rows will be gender. And we're just going to put support as the columns. And to make our life a little bit easier, we'll put in row percentages. And just click OK. Pull up our output. Now some things we can just get rid of, just to clean up our output. So this is the table that matches the crosstabs table that we want. Now we want the table of means, and we'll go there by going to Analyze, Compare Means, and we're going to need apprentice, ward, and age. So we go apprentice as a dependent, ward, and age. And the independent, it looks like we're going to need gender and support 2. Just click OK. And we're going to delete what we don't need. And here we have gender, which would give us the first part here, and the other support 2 gives us this. So now we're ready to go. We're ready to take the test. And we'll put up the questions. How many males supported themselves? Well, it looks like there's 4. How many females supported themselves? Looks like there's 8. What proportion of males supported themselves? Well, it looks like 0.308. of the students who supported themselves, what proportion were males? Okay, so there's 12 who supported themselves, 4 were males, so that looks like 0.333. What proportion of the samples were males who supported themselves? Well, that looks like 4 divided by 30, because the sample's 30. We're going to pull up our calculator now. And 4 divided by 30, we could do this in our head, but we won't. 0.133. What's the mean of apprentice for male? And the mean for apprentice for male looks like 4. What's the standard deviation of apprentice for male? 1.08. What's the mean of apprentice for female? 2.47. What's the mean of ward for support by family? Okay, so now support by family, 3.17. What's the mean of ward for support by all categories other than family? It looks like 3. What's the standard deviation of apprentice for support by all categories other than family? 1.414. What's the standard deviation of ward for the entire sample? Looks like 0.765. What's the absolute frequency of 22-year-old males? Okay, now we're going to have to change this a little bit. We're going to have to go back to our SPSS file. And we're first going to sort ascending the age variable and then the gender variable. This just lets us work from our raw data. But what's the absolute frequency of 22-year-old males? So we see there are 13 males, 17 females. There aren't any 22-year-old males, so we're going to say 0. What's the relative cumulative frequencies of males 22 years old or less? Well, it looks like there are 6. We'll have to pull out our 6 that are less than 22, so that would be 6 divided by 13, that 0.462. What's the absolute frequency of the interval between 20 and 24 for females? Okay, between 20 and 24, so we've got 1, 2, 3, 4. What's the relative frequency of the interval between 25 and 29 for females? So the absolute frequency is 1, 2, 3, 4. So the relative frequency would be 4 divided by the number of females, which is 17, and that gives us 0.235. What's the relative frequency of the interval between 25 and 29 for males? Okay, we've got 1, 2, 3, 4. Again, we've got 4, but now we're going to divide it by 13 because there are 13 males. 0.308. What is the area under the normal curve between 24.5 and 9.5 for females? Okay, we'll pull up our probability calculator and we're going to use area between. And the low score is going to be 24.5 and the high score is 29.5. And now for females, we need our data back here, our output back here again. For females, mu for age is 23.76, and the standard deviation for females is 5.345. Now we can find the probability, 0.30. And we'll just put the whole thing. What's it for females? 0.303. 304, 303 would have worked. Now we want to do the same thing for males. So the low score and the high score is going to be the same, but the mean is going to change. 23.69 doesn't change much. And sigma 5.298. And the probability 0.303. Okay, next we ask for the interval that we just did, which normal curve had a better fit for females or males? Okay, well, the actual number is 0.308 and the predicted for males is 0.303, so that's almost on the money. For females, the actual was 0.235 and the normal curve model was 0.303, whatever. So males are the better fit. We just look at the difference, the absolute difference, and the smallest absolute difference is the one we'll choose. Okay, A. What would be the best estimate for the parameter mu for the normal curve model? 23.73. For the parameter sigma, same thing. 5.232. What is the sum of all the ages? Okay. We can do this by looking at analyze. Now I'm just going to take age and the statistic, and I'm also going to, I know the next one we're going to look at age squared, so look at age and age squared. The statistics we'll look at will simply be the sum. And OK. We don't really need the frequency table. All we really need is the sum. So the sum for all ages, 712. I could have just taken the data on the Excel file and looked at the sum there, but we did it this way. What is the sum of squared ages? We saw that. The sum of squared ages is 17692. The sum of ages squared, so the sum of ages is 712, and I can just square that and get 506944. Okay. In a kiwi bird problem with mean with n of 4, so there are 4 kiwi birds, means 4, median's 3, and mode is 2, how many birds are 3 feet tall? Okay, so if the mode's 2, we need 2 birds that are 2 feet tall. If the median's 3, the third bird has to be 4 feet tall, because when we have an even number of scores, the median is the midpoint between the two middle scores. And the sum, to get a mean of 4, the birds have to sum to 4 times 4, or 16, so the fourth bird has to be 8 feet high. That's a big bird. How many birds are 3 feet tall? Well, there aren't any. How tall is the tallest bird? We said the tallest bird was going to be 8 feet tall. Okay, what is the median age for males? Okay, we're going to do this. There's any number of ways we could do this, but the median age for males, we could just look at it this way. So there are 13 males. It would be the 7th. Looks like it would be 25. What is the mode for females? Well, there are 2 16s, 2 18s, 2 24s, 2 25s, 2 31s. So there are lots of modes of ages for the females, but the smallest is 16. So we'll take the smallest one. And for the age variable for family support, which is larger, the mean, median, or mode? Okay, we're going to do this by, first of all, looking at data, and we're going to select cases. And if the case is satisfied, so if support 2 equals 1. In other words, that's the family. And click on OK. So now we're just selecting the cases, the records that have family. Now we want to analyze descriptive statistics, frequencies, and we no longer want age or age squared. We want age, I guess. We do want age. The statistics, however, we no longer want the sum, rather we want the mean, median, and mode. So we're just finding the mean, median, and mode now for the age variable for just the students who have family support. And I'm going back to our data table, our output, our SPSS output. And the mean is 23, the median is 24, and the mode is 25. So it looks like the mode is the largest. Okay, we've put everything in. We've put in all our answers. We don't have to fill out the table. And time of reckoning is upon us. We click on Submit this assignment, and voila, we have a score of 30. And that is how you do the problem part of Test 1.